Hello, everyone. Thanks for joining me today, the session. And as I got introduced, I'm the product manager in the VMware solution offering with management tools. Before I start up with the session, I just want to quickly get some survey done here. I just want to see how many of you are part of sysadmin, infrastructure ops. Okay, and how many of you here are part of developer, like developer community, development team? Okay, and how many of you are kind of cloud architects who are responsible for defining the cloud services? Anyone here? Okay. Did I miss out anyone? Probably I'll just cover it. How many of you here are VMware users? Okay, and how many of you are Puppet users? I'm just kidding. Thanks for that. So you know that just to outline what I plan to cover in today's session is specifically around, everything started with the infrastructure and moving up to the application layer part of it and how automation and management plays a big role in that. And it is very interesting going back to today's morning keynote from Luke where he mentioned that, what really it means about automation from infrastructure and the application and what it means to the business is the time to market is the value that they look at it. That's what they call it as a true agile thing that you deliver the value as. So I'm going to quickly go introduce about the various solution offerings from VMware and how it kind of have integration with Puppet. And I have Gareth here also from Puppet, who's going to cover on the vSphere module, specifically around managing the infrastructure, managing the vSphere infrastructure as well. So just to lay the fundamentals here right, so everything started with IT as a journey, and today we're here looking into hearing more about DevOps, and that's where things have changed the focus from more of app-centric. Okay, I have taken up server consolidation, and I have automated it, and pretty much then once all the pieces of the infrastructure has been automated and laid out, and it comes about the more of application, laying down the application tier on top of it to making sure that you orchestrate them right and manage them right with kind of making it more automated by policy-driven automation. So the real key thing here is VMware has been looking into simplifying this process of standardization, which is the first step to automation. So you abstract out the most meaningful logical components and tie them later on with trying to introduce the loose coupling between the physical infrastructure and the logical components that you derive as the standard components. And then kind of try to introduce the automation, of course, by managing through various policy-based automation when I talk about it. So looking at it we are looking at more about empowering the IT from starting with building the services to today looking into how they act as a broker so that it kind of trying to make them accelerate the service delivery when it goes back to communicating between the various silos of different teams when you look into the internal users and also communicating with external users. So that goes back to also managing and automating across various different platforms, looking into hybrid nature platforms and physical infrastructure from various providers as well. So when you look into the life cycle, infrastructure has its own life cycle and also application has its own life cycle. So when you look into it, you pretty much look into the modeling phase where you build and model the infrastructure and then you lay down the automation piece and trying to configure them and deploy and monitor and manage part of the day-to operations. And so this is where we're looking into what it means for various management tools to focus on. So the management has to look into the various attributes specifically around stepping into once things have, from VMware's perspective, when we call it as a software-defined data center, as you know that underneath there is a physical layer, as my favorite term that I put it as a AAA concept is around you abstract and then you aggregate and you allocate them in a much more efficient way, right? So once you abstract them and standardize them with the various compute infrastructures, like starting with compute and network and storage, then you lay down the fundamental piece of trying to automate them by introducing the policy-based automation and governance and control checkpoints, various checkpoints across various management layers there. So that is where we have the vRealize automation solution offering a self-service catalog, which I'll go over in a minute to showcase like how it produces various elements and trying to provide an app store like an user experience in order to automate and also accelerate the self-service of various components, starting with infrastructure layer to application layer as well. And we have the operations, specifically about once you automate it, it becomes very important to look into how the various elements like health checks and performance monitoring, and also kind of looking into the capacity of how much has been allocated and how much has been currently been used, and if there is any kind of shortage in the capacity versus the usage, and how do you kind of take appropriate corrective measures to put back into facilitating into much more efficient ways. And also, that is specifically about vRealize operations. And again, moving on is about trying to showcase them to the business. The business is more interested about looking into the visibility of how much does it cost, how much are, like each and every organization has been allocated with various reservations of the capacities, how much are they currently using it, are they currently kind of, it works with the chargeback mechanism of showing back the cost associated with each and every infrastructure usage as a process. So we have vRealize Business around that, specifically to provide solution for CIOs to look into getting more visibility into the cost associated with each and every services and the usage around that. So I'd like to quickly touch upon the tale of two teams, specifically about, again, this what I would take reference back to today's talk from Luke in the morning in the keynote, where he mentioned that is, there is no specific one way of doing certain things. There is multiple different, 1,000 different ways to achieve things, right? So when things are not defined or standardized, the standardization, the key concept is around like trying to introduce a consistency where you can make sure that is things are rendered in a more predictable manner, in a much more predictable and consistent way across various platforms and also various teams. So when things are not laid out appropriately by trying to abstract out and giving them a solution, what happens is infrastructure team and a solution team, which pretty much manages the different kind of pieces of the components, they work in different disparity by trying to leverage the things and introducing the way that they consume Puppet or define them within a different format. It's pretty much kind of they consume in the way that they have expertise in. So it creates a lot of inconsistency, means that kind of inflexibility in there. So where it goes unmanageable at a point where they cannot scale, or even like the way it has been consumed within the application model within the application team cannot be kind of used by the infrastructure team when the kind of accountability is not laid out properly. So that is where it goes back to defining, modeling a solution where it kind of you call it as a true DevOps model. So what VMware has to offer here is it's trying to abstract out, as I mentioned, and starting with infrastructure layer and leaving it to the machines to communicate, and also defining the various components, the middleware services as part of application tier, and trying to lay down on top of them and define them as kind of an application blueprints, which could be standardized and used in a repeatable way, so that you model once and repeat, use it in a multiple different different places to deploy. That goes back to various environments and trying to propagate them across various pre-production, production environments. So of course, management is an important concept there. So where you introduce various levels of management through policies, being for infrastructure management, and also policies to manage the machines, to say like what set of machines are staying together, saying having to deploy a database server and also have these machines to stay close with an app services, application servers to communicate them in a much more reliable way. So I want to quickly touch upon the app services, which comes with vRealize automation solution, and it has a drag and drop interface where on your left, as you can see, that it has various logical components, as I mentioned earlier. So it gives you various logical components starting with the OS layers, and also it has the various servers like middleware components. And on the right, you have like various external services and also the application components starting with kind of binaries or any artifact types like var, jar files, or exes or whatever it did. So what the user interface lets you is you can define your application topology starting with like, you need a database server, you need multiple app servers and a web server, and then you have a load balancer to stitch them to orchestrate across the various app server when you have more than one app servers. And then you define the middleware component, let's saying like, if it's going to be a middleware component like Tomcat or Apache, which is used as your web or app servers, and you can define those things by drag and dropping the various components. So it goes back to associating with the various personas. So when I asked you earlier about a developer or a cloud architect pretty much goes back into gaining access to modeling this application tier as a deployment topology, saying, okay, this is my application stack, and have these many nodes pretty much, to build that application stack and define these various components and create this as an application blueprint. So once you create this application blueprint, it becomes as a model which you can publish it into the catalog, and which is where it kind of becomes as a consuming part where you can various developers can consume them by trying to request them and trigger it, manage them various deployment. So it also comes with the policy management where you can introduce like who gets access. So starting with like, the first step is to who gets to define what and where are those resources going to be allocated. And then the step is to, from when you get into access part of the consumption, the users, internal users, they get to say like, who gets what and from where, right? So you can define various business groups, and then of course it has a multi-tenancy feature along with it. And once you define various set of users and user personas within the user group, defining the various roles, role-based access control, and then they get to tie it to the resource reservations from where all these resources will be consumed and allocated at the end of the day to manage those appropriate blueprints when it gets deployed or provisioned in case of infrastructure or application provisioning. And then it goes back to stitching it to the other logical component, which is the service blueprint. So it kind of gives them much more granular access control to tying into various pieces once you abstract out the logical components from the physical layer, and then stitching it to the various deployment profiles, saying who gets what and what other various resource types are getting stitched together, and when it gets deployed, it will be managed by accessing and based on this policy-driven management. So this is the service catalog which I just mentioned. So once you, any kind of infrastructure blueprints, you can think of saying, the CentOS machines, or it could be like IPAM or any network profiles, or what you configure as infrastructure services. You can publish them along with the application services, service components. It could be a Tomcat or a database server as a standalone component, or could be an application stack for the internal user consumption. So you can build them and model them, and you classify them as blueprints, and you can publish them into the service catalog, where it becomes as an end-to-end delivery mechanism to accelerate the service delivery. So users can get access to this service catalog, pretty much trying to provide an app store-like kind of an experience where the users can choose, okay, I need a database server, I need an app server, or they can actually go back and say, okay, I just need this application, and then it's going to say underneath, basically, it's going to provision all these machines and make accessible to all the infrastructure which is need to be provisioned on below that. So it's kind of trying to abstract out and trying to create a user experience and trying to make sure that appropriate users get the right kind of access to manage them and deploy and manage within their silos. So what actually moves on to is the specific around the configuration management. And of course, with our community-driven approach, we have an extended 1,000+ Puppet modules, and also, where it could be idea here is to how do we leverage that? It's leverage those kind of configuration management modules that the user community has been providing, and to extend the approach of all the services in order to complement and also to make it more agile in the way of the user community to use it, and for the business to start deriving value from that. So we have, of course, we have several plugins, and of course, I would like to bring in Gareth to speak about one of our vSphere module, which is specifically around managing the vSphere infrastructure and lifecycle. So Gareth would speak about it.
Oh, thank you. So, brief introduction. I'm Gareth Rushgrove from Puppet Labs. I'm one of the senior software engineers, and one of the things that I've been working on has been some of the vSphere integration. Some of it's really sort of the problems we observed from seeing lots of our customers, lots of our users who are sort of big VMware users, struggling with some of the things that are quite common in lots of large organizations that are starting to embrace sort of DevOps practices. Some of it is that everything suddenly wants to go faster, whether that's creating new machines, deleting machines, changing the machines, adding more memory, taking memory away, just balancing things. Everything suddenly wants to go faster. Another part is that there's now more things, so management over time becomes more precious, more pressurized. And making all of those changes manually just starts to become a problem. It becomes a sort of stone around everyone's neck. And things are going away more. And given that everything's moving faster, given things are changing more, keeping that diagram up to date, keeping that spreadsheet up to date about how these things are, it is never going to happen. It's not something that we can do manually anymore. So we took the the approach that Puppet has taken for managing individual server resources, so files and services and packages, and sort of thought, well, what would that look like if we were managing virtual machines in vCenter? How could we manage things over time as well as optimize for creating new things? How could we help with managing that sort of drift? If I create a VM today, how do I know it's still got the same memory and CPU allocation tomorrow if suddenly lots and lots of people have access to the VMware console? And really what we sort of came up with was actually infrastructure as code, what Puppet is based on, maps really well to this problem as well. So the vSphere module allows you to do this sort of thing, just declare in code, in Puppet code, that you want a VM. You want it at this location, you want to make sure it's running, maybe you want to make sure it's stopped. You want it to be based on this source, you want it to be a linked clone, you want it to have this networking integration, you want to run this customization specification when that VM comes up. So the module really just introduces this single primitive. But from that single primitive, well, you can describe, use the Puppet language, so use the defined types, using the new language features, to describe higher level constructs. So you could describe a specific application stack, and maybe you just provide an interface to a team where that just says, well, how many application servers and how many web services should that stack have? And under the hood, you're using this type to basically actually make sure they exist. And the nice thing is you're creating that model of your infrastructure in code. And we know from how we've managed server infrastructure that then allows all sorts of goodness, whether that's using unit tests to impose policy, whether that's actually integrating that with continuous integration, whether it's allowing a lot more people to actually contribute and change and understand the infrastructure without giving them direct access to push those buttons. Lots of organizations have a small number of people with the actual access to the sort of the manual console, because there's so much power there that even with access control, there's a barrier to entry, especially for sort of development teams that just want that infrastructure to exist. Here we can just declaratively model that infrastructure in code and have it all realized and enforced over time. put some more bits here. So then it becomes not just about the individual VMs. Being able to describe those in Puppet code is interesting, but the really interesting thing is where you combine a number of them with a higher level things, and also with some of the things like the network devices modules. So basically, you can be describing not just the VMs, but describing maybe an F5 load balancer, maybe a Cisco switch, and tying all of that together with Puppet code. So the module is available now. It's part of the Puppet Enterprise suite of supported modules. And so if anyone's a Puppet Enterprise user, do check that out, do feedback. We're definitely going to be adding more features to that over time as we get more feedback from people. So, and I'll hand back over to Raj.
Thanks, Gareth. So Gareth just mentioned spoke about specifically how you can manage your infrastructure using the vSphere infrastructure using Puppet module. So there is other way specifically that we have, I would like to introduce to vRealize Orchestrator. It's one of our easier simplifying any IT automation of tasks, to which we use it as an extension and it integrates with various vCloud service components. And it is the way that we kind of have a new plugin which is built specifically, which has been there and shared with the VMware community and also the Puppet community through the VMware Solution Exchange. And one way, the few specific benefits that we get by trying to integrate through leveraging the vRealize Orchestrator, which again, I'll cover in a minute about what are the various the benefits that you get to, or the usage-wise, how you can use it in the Puppet context. But specifically looking into it, it's much more extensible, trying to integrate with various vRealize suite and also other VMware components, which I'll touch upon in a bit. And also, it as kind of goes in a separate release cadence. It doesn't tie us up with any of our product releases, and it could be easily incorporated based on the feedback that we get from the community to incorporate and then extend that to our community back. And also, it makes it much more quicker in the way of making it to the readiness to enterprises. So again, as I mentioned, that vRealize Orchestrator is a simplified approach to build and automate any IT tasks. And it comes with a modeler where you can actually define the workflows, which is what going to be like. I'll be going over specific Puppet-based workflows that is built to comprise this Puppet plugin. So these are the various, these are the various Puppet workflows that has been currently made available as part of the vRealize Orchestrator plugin. Specifically starting with how the users can actually go and register their Puppet masters and also make it available as part of the vRealize Orchestrator's inventory. And also going back to it supports HERA-based or manifest-based, Puppet manifest-based node classification, using which all the node classification can be applied once the agent is installed on a particular node, and it could be managed using the Puppet. And that's where the node management also comes into picture, and trying to certify the nodes, various nodes which are managed, which the user wants to manage through Puppet. And also it has both Windows-based and Linux-based install agents workflows specifically. And today the rack support is currently in the experimental phase, where we have basic functionalities to add specific nodes using rack and also manage them. And again, as I mentioned, these are the various basic workflows to leverage the the Puppet lifecycle through Puppet. And once it is kind of the plugin pretty much comprises of putting together all these workflows, and it could be leveraged in the form of the sample workflows, which is currently shared in the VMware Solution Exchange, or it could be the users are more than welcome to take it up and then customize it based on their specific requirements to leverage the way that they use currently in Puppet in their organization. And looking into the specific use cases around the integration with configuration management, it goes without saying that it starts with how do we install the Puppet master, and also the making all the nodes which needs to be managed through Puppet to be enabled by installing the agents on them, and introducing the authorization to share the clean certification across to make the handshake across the master and the specific nodes which are getting managed through Puppet, and also the role-based profiling and role configurations and role assignments to specific nodes which are getting managed through Puppet. And once it is role assignments are made, then how do you actually apply any modification to the roles or the profiles, and and through the remediation process, and also through the tear down. It leads to the tear down of the nodes. So again, it goes back to the plugin itself as an extensible model. It could be customized, and it's kind of comprises of putting together all the bits and pieces of the different workflows. And list of workflows, as I mentioned, it supports this use case to starting with the lifecycle to install and manage those Puppet agents on both the Linux and also the Windows nodes, Windows-based nodes, and also authorization through the certification and node classification using Hera and Manifest. And this is currently available in the VMware Solution Exchange, and it supports both Puppet Open Source and also Puppet Enterprise. And it's kind of welcome to leverage and be customized. And as I mentioned, that the reason that we have introduced VRLH Orchestrator workflow as a plugin here is to, with the given nature of its support with various integration and support with the various VMware products, it is easy currently integrated with VRLS automation to automate your workflows through and Puppet Manifest, leveraging the Puppet Manifest and rendering those Puppet modules and service components within, automating the service components within VRLS automation. And I just want to quickly introduce you to other VMware solution offering. I'm not sure how many of you have heard about VMware solution, DevOps solution offering here, but I just want to quickly introduce you to VRLS CodeStream. So here we have the VRLS CodeStream specifically has been modeled towards a solution offering for release engineers or the DevOps engineers to enable them to make their releases much more streamlined and make it more automated from end to end when you call it as a true agile model by stitching together various components starting with your developer workflows to the integration workflows and leading it to the deployment workflow, which is the three different workflows which comprises to call it as a continuous delivery model. So what we have in front of you is pretty much trying to, it comes with a user interface where a modeler, which you call it as the phase one, where it lets the application architect or cloud architect to come and actually model the release pipeline, which you call it, as I said. Everything starts with the automation has to be standardized. So you abstract out the logical components, which you call it, define it within the phase of release, and which could be as simple as the different workflows I just mentioned. And it could be, starting with once the developer checks in the code into the repositories like source code management systems like Git, Perforce, or Subversion, and then it gets picked up by your build servers like continuous integration workflows like Jenkins or Bamboo or TFS, and then which creates your artifact, which is pretty much becomes your deployment unit as a WAR file or jar file or an RPM package, and gets pushed into your repository of your choice. And one thing to keep in mind is CodeStream comes out of the box with an OEM support to Artifactory. JFrog Artifactory is one of our partner. And we leverage the Artifactory's integration and support with various other popular repository systems out there, starting with Maven, NuGet, or the file systems that it has. And currently it has introduced the Docker Hub support as well to consume the container or Docker images. So what it really does is brings in the release team to work. DevOps becomes a collaborative between the dev team, QA team, and DBAs and the cloud architects who kind of work together and to try to build this release platform. And we call it as a release pipeline. And we define the various stages that you looking in front of you, as we're starting with dev, staging, or testing environments, pretty much comprising of all the pre-prod environments, and listing out the various layers, like the key activities, like, okay, what do you want to do? You want to first provision you want to first start with building triggering a Jenkins build from within the code stream, and then once the artifacts are getting built, and then it gets pushed into any of your Artifactory, and we have an artifact management solution built around Artifactory. Again, it acts as a proxy to connect to your various repository systems to resolve those artifacts. So within CodeStream, it lets you lets the modeler define the resolution path, saying, okay, this is my artifact, and this is the kind of, you can define this kind of certain parameters, like defining the parameters like versions and build number, which are kind of pretty much becomes a dynamic in nature. So only during the execution it becomes available. So all these tasks, each and every task becomes a computing unit. Each and everything has a set of inputs defined to it in the form of parameters. It could be either at the task level or it's at the pipeline level, where it needs to be kind of stitched together across various tasks. So the task consumes those input parameters based on this nature of activity it needs to perform, and define how within the task, within the modeler itself. And then you get into the phase of trying to orchestrate and saying, like, okay, this particular task, for example, is a Jenkins task. Then it would give you the set of artifact and where it is getting pushed. And then that is the the next set of tasks, like provisioning, which is the provisioning underneath it. It leverages the provisioning engine like VRA, or it leverages Puppet as well, which I'll showcase in a minute, how the VRO plugin can be leveraged within the context of release pipeline. And then it orchestrates across various stages to say, okay, I have resolved this artifact, and this is the machine which is pretty much, I want to define a web server and a database server, and then the IPs becomes runtime available, and then it communicates to the underneath the following subsequent tasks, where it can say, okay, this is my artifact which I want to use this deployment script and deploy within this provision machines. And then once it is defined, it wants to trigger a Selenium test process or a regression test suite. You can do it within by defining within CodeStream modeler itself. Again, it becomes like a hook point to various tool sets that currently put in practice with the various release engineering team or the DevOps team, so that it stitches together and orchestrates the workflow across in the context of pipeline, release pipeline. And it also, one thing to keep in mind is things are very important to create visibility and also introduce governance across it, because of course the governance is the various kind of mitigates the risk of making sure the right set of artifacts which are getting developed and tested are the ones which are getting certified and made available and deployed within the production environments. So it has various gating rules, which is the ones which are in between various stages here, and lets the user define what kind of gating rules. It could be as simple as triggering an email notification and getting an approval workflow, to letting the supervisor say, okay, supervisor says, okay, this is the release certified build, and this artifact is certified to be deployed within the production. Or it could be as simple as automating it by reading the test output scenario, where the Selenium test case comes back with a 99% of the pass rate, and in which case it lets the automation to trigger the execution to flow to the subsequent stages. Again, it has various other features as well, and which I'll be covering in a separate session, which I'll share the specific details. But here again, also it has, once the execution is done, it gives enough visibility to the release team or the various stakeholders in there with the context of release, to gain visibility into what sort of artifacts are getting built and where it is getting deployed, and where it's the current process of release is standing today. So getting back in the context of Puppet, so where I mentioned that we have a Puppet plugin, and the plugin can be leveraged in the form of a service blueprint. So once this currently consumed within the code stream as a Puppet plugin, we call it as a service blueprint. So here, this kind of within the context, the user wants to automate the deployment and process of defining an Apache server as a node by leveraging the Puppet module. So what he has to do is, so it is, as I said, it's already registered as, and once you register this as an endpoint and leverage this plugin, it gives you access to define where is the Puppet master. It could be multiple Puppet master, and lets you choose which Puppet master you want to leverage here. And once you choose the Puppet master, then it kind of exposes the various set of pipeline level parameters. You can define, okay, these are the set of environment types, and these are the set of environment specific values of the versions that you can define within the context, and also any type of credential which could be parameterized and make it available and defined during the runtime. And once those are defined, then again, it lets you also configure the various node classifications on which you want to leverage from within the Puppet modules. And you can let it saying, okay, once a node has become provisioned and it is, Puppet agent is installed and managed through Puppet now, you can actually also define your node classifications to manage them. So this is the way that you can actually do it one way or the other right now. And also keep in mind that DevOps is more about like not just specifically applies to application, but it's also extends it to any kind of service level components. When we say components, it's pretty much looking into software-defined data center. You can think about any logical components that I mentioned, right? It could be a template, blueprints, or it could be any middleware services that you build, and it could be as a Puppet module itself, right? Everything has kind of goes through the life cycle. So this life cycle has to be automated and managed. So the approach we have taken is kind of introducing the DevOps for IT, which is where like all these kind of things can be developed and tested, and also they're kind of a pre-built packages we have defined, and we plan to release it later sooner this year as part of management pack for CodeStream, which is a pre-built pipelines, release pipelines, which users can leverage to define the lifecycle and manage the lifecycle of the process of various components. So it also helps in going through the various phases of test and making it eventually delivered and deployed within consumed within the context of production releases. So this is what I just mentioned about the DevOps for IT. This is a CodeStream management pack, which will be introduced sooner this year. And it is, again, goes through the process of managing and orchestrating the life cycle of the content management. And again, it is to keep in mind is comes as an extensible framework that users can actually leverage the set of REST APIs and build their own custom plugins, and also help in kind of leveraging any VRO plugins. It currently, as part of the community, there is a VMware community, there is a lot of IT automated tasks which are pre-built and exposed and shared in the VMware Solution Exchange. This is the marketplace where you can have hundreds and thousands of solutions which are shared by the community. You can go and leverage them in the form of VRO plugins and can leverage within the CodeStream. So with that, I just would like to conclude by letting you know that I would be getting in more detail specifically about sharing the DevOps solution, which I just mentioned about CodeStream, in tomorrow's sponsor theater session, where I most probably will be giving a short demo as well. So with that, I just want to conclude and open up the floor for any questions there. Yeah, we have there.
Hey, this mic. Yes, it works. Definitely.
Can you talk a little bit more about the blueprint stuff? It looked like you could just sort of drag and drop like a database and then an application server and all that stuff on, and then hit go and spin up a whole bunch of virtual machines for that.
Sure. So the blueprints is a concept as, again, it could be an infrastructure blueprint or an application blueprint itself. I believe they are talking about the application blueprint, which I mentioned about as part of the VLS automation solution. We have application services, which comes with a modular graphical user interface, where you can application architect can work along with the cloud architects to define their deployment topologies in the form of application multi-tier blueprints, right? When you think about multi-tier applications, you want to define like various components within it, starting with the layer of operating system, right? So when you call it like, so there are two aspects to it. One is the infrastructure provisioning and then the application provisioning, right? So once you need to enable what sort of infrastructure is required. It could be starting with you need a CentOS machine for your entire application stack. Then what it does is, let me bring in quickly the specific slide just to give some context around that, right? So it helps in actually bringing in that drag and drop interface where trying to, is it the one? Yeah. So you have those various components which you call it as a logical components. So you make it more loosely coupled. So it's saying that it could be, you define those various operating systems, which is pretty much when you deploy, it provisions a new virtual machine coming along with the deployment of an operating system of your choice. And then you can define, okay, what middleware component that you want to leverage. It could be any of those components starting with database servers or RabbitMQ servers, or it depends on the kind of a tier that you want to define in the middleware service on top of it. And then it's where you deploy your application component in the form of any kind of binaries or binaries that you want to deploy onto, right? And you would define your deployment mechanism in the form of either, that's where I mentioned as it could be a Puppet module, or you can define it in the form of a script where you want to leverage and say, okay, this is how you want to install and deploy. And all these things goes through a life cycle. So today it supports both day one and day two operations. So day one is pretty much, once you model, you kind of define, okay, during the execution, once this blueprint is published within the service catalog, which I just showcased earlier, and the user can actually, a developer can quickly go and say, okay, I need this application stack, right? Underneath it creates all these virtual machines and have these operating systems provision on top of it, and have the application middleware components like middleware services kind of provision, also deploy those application on top of it. And it manages all the dependencies, like once the first thing is to database servers to come up, and then it comes the web and app tier to follow by any kind of load balancing mechanism that you want to introduce, right? So it manages those dependencies and make it available for the user in a seamless way. Does it answer your question? Yeah.
Maybe I have time for one more.
In the vRealize orchestrator, as far as node classifications, you can use Hierodata or manifests. What about node groups? Can you manage those?
So currently we don't have the node groups. So what we have surfaced is it's kind of a building blocks, right? So what we have introduced is all the node classification exposed as form of individual classes, and the plan is to, of course, get into the profiling and create the node groups on top of it, and which is really not there, and we plan to do it sooner with the support of our Puppet community as well. So yeah.
Okay, and the other piece you were talking about at the end, the DevOps for IT.
Yep.
How does that tie into all this?
So DevOps for IT is specifically around the release automation solution, which I just mentioned about CodeStream. So CodeStream is going to come up with, it's been there for past several months. It's GA'd in 2014, and I had a follow-up, a few releases as well, and we have this management pack specifically to cater the IT admins on to how do they manage their IT content and lifecycle, right? So today, so once they step into the automation, they have to define the various bunch of blueprints, scripting, and then they have those things goes through the similar lifecycle as a code, right? So you can think of the infrastructure as a code, or when you define it as a Puppet module, it needs to go through a development and then test, and then it gets into production as such, like to consume for the internal users and along with the external customers, right? So those could be easily managed by using this automation workflow is a release pipeline, which comes out of the box.
So that'd be like your Puppet code and whatnot?
So this is going to be a CodeStream management pack, and it could be used to manage your Puppet manifest, or or any type of other defined components. As I said, it could be blueprints or any IT content.
Okay.
And
Thank you.
Thanks, Suraj.